In this video, I will show you how to solve problems involving sector area. A sector is some portion of the interior of a circle. So this sort of pie piece that is shaded dark gray, this is a sector of this particular circle. And we will be dealing with the area of shapes like this. So the key is the sentence that I have written right here. Sector area is a fraction of the total area. That is obvious. So how can we take this and turn it into a formula? Again, sector area is some fraction of the total area. I'm going to use the letter A to represent section area. Equals is a fraction. So what is this fraction that I'm talking about? We know that the total number of degrees in a circle is 360. This angle, the central angle right here, I'm going to call this theta. All right, that's a little bit hard to see, but I'm going to call that theta. That gives us the fraction that we're talking about. This theta represents a portion of the 360. So theta out of 360, that's the fraction of the total area that we are dealing with. So far I have sector area is a fraction. Now, what about the total area part? What is the formula for the area of a circle? That is pi r squared. So if I put the pi r squared, that completes the sentence. Okay, so here we go. Sector area is a fraction of the total area. So we have now transformed this common sense sentence into a formula. So that should make it easier to memorize. So it's just a matter of looking through the problem, figuring out which of these three variables we are given. Hopefully we are given 2 out of the 3. The radius of this circle is 4. So we know that r is 4. What else? The area of the shaded sector is 15.6 square inches. All right, so we are given the radius, but we are also given the sector area. So let's substitute both of those things in. So we know that 15.6 is equal to theta over 360, okay, times pi. Okay, the radius is 4, so this would be pi 4 squared. We might as well go ahead and square this, and we'll get 16. So let's just go ahead and put 16. I welcome you to skip this step and go straight to what I'm about to write next. This pi and 16 is going to end up in the numerator. So this is the same thing as having 16 pi, right? Pi times 16, 16 pi, that's the same thing. But all of this is over 1. So this is all in the numerator. So I'm going to put all of it in the numerator. So I'm going to have 16 pi theta over 360. Next, I would really like to reduce. I like smaller numbers. So look at this 16 over 360. If I put that in the calculator and reduce it, it turns into 2 over 45. So you don't have to do that, but I recommend it. So I'm going to get 15.6. Now here comes my 2 over 45. Instead of the 16 over 360, I still have the pi theta. So we just need to get theta by itself. We are supposed to find the measure of arc AB in degrees. That is the same as theta. Okay, the arc length in degrees and the angle in degrees are both theta. They are both the same thing. So to get theta by itself, we need to multiply by denominator. We're going to multiply both sides by 45. These 45s will cancel each other out. So 15.6 times 45. 15.6 times 45. 702. That's nice. So I have 702 is equal to 2 pi theta. In order to get theta by itself, we need to divide both sides by 2 pi. And this will give us the final answer. So we will have theta equals whatever this is. Okay, by the way, when you do 702 divided by 2 pi, please notice that you will get a different answer if you set it up as a fraction like this. Okay, so this is the correct answer, 111.73. Let me go ahead and write that down. 111.73 degrees. Let's get those units in there. All right, so this problem is done. But I need to point this out to you. Here's a common mistake. Some students will do 702, and then they'll go divided by 2 pi, and they will think they will get the same answer, but they won't. Okay, even if I turn this into a decimal, boom. Okay, that is way, way, way off. The problem is when you do 702 divided by 2 pi, you're really only dividing by the 2 because of the order of operations. You divide by 2, and then you're actually multiplying by pi. If you want to divide by 2 pi without making a proper fraction, you have to use parentheses. So if you want to put this all on one line, you have to do 702 divided by, but then you need to put the 2 pi in parentheses. Okay, then you'll get the same answer. But if you have the fraction button, use it. Well, problem number 4 is almost the same thing. We are still dealing with sector area. So let's get the formula written down. We know that sector area is some fraction of the total area. And the formula for total area is pi r squared. So this is the formula for sector area, some fraction of the total area. So we are given the measure of arc AB is 123 degrees. That is theta. It doesn't matter whether they tell you the central angle is 123 or if they tell you that the measure of the arc in degrees is 123 degrees. Either way, that's theta. So what else do we know? The area of the shaded sector is 22.7 square feet. So they are giving us the sector area again. So they are giving us A. So the 22.7 goes out in the front. And we are given that theta is 123. So we have 123 over 360. That leaves us with the pi r squared, which I'm just going to stick up here in the numerator. So I've got 123 pi r squared over 360. So I need to solve this for the radius. I need to solve this for r. Normally I would reduce this, but 123 is a prime number. It is not going to reduce at all. So we are just stuck with big numbers. I'm going to multiply both sides by the denominator of 360. So I'm going to multiply by 360 on the left and right. That way these will cancel each other out. And it's just a matter of what is 360 times 22.7. 8,172. So I've got 8,172 is equal to 123 pi r squared. Let's go ahead and divide both sides by 123. So I'm going to divide both sides by 123 and see what I get. In fact, so we're trying to get r by itself. So we need to divide by 123 and pi. So let's divide both sides by 123 pi. And then we're going to see what we get. So here we go. Fraction mode, got to use the fraction mode. 8,172 over 123 pi. If you don't want to use the fraction mode, or if you don't have fraction mode and you have to use the division key, don't forget to put the 123 pi in parentheses. So this is what we get. Unfortunately, this is not the final answer, so we cannot really be rounding right now. So we really need to keep all of these decimals as much as possible. I don't feel like writing down, that's a lot of numbers. So you know how we normally will round to 2 decimal places? I'm going to write down the first 4 digits. That will save me from rounding error later. So let's go ahead and write down the first 4 digits. So I've got 21.148. I'll go ahead and say 1482. Okay, this is more decimals than we would need if this were the final answer. But we have one more step. If I want to get r by itself, I need to take the square root of both sides, all right? That's kind of how you unsquare something. So this is going to give us the final answer. So I need to do the square root of 21.1482. Okay, so now I will round to 2 decimal places. So this is 4.59, but this will round to 4.60. And what are the units? The lengths are in feet, so the radius will be feet. Take a look at problem number 6. A smaller pizza is also cut into 8 congruent slices, each with a central angle of 45 degrees. If each slice has an area of 19.24 square inches, what is the pizza's radius? So the key is we're talking about each slice. So just focus your eyes on a single slice of pizza. That is a sector. So here's the formula for the area of a sector. We know that the area of a sector is some fraction of the total area. Okay, it doesn't matter that the pizza is cut into 8 congruent slices. We're just dealing with 1. What matters is that the central angle is 45 degrees. That tells us that theta is 45 degrees for one sector. Each slice has an area of 19.24 square inches. So that is the area of one sector. So that tells us that the area of the sector is 19.24 square inches. So we are given theta and we are given A. So let's go ahead and substitute those in. So we've got 19.24 equals 45 over 360. Now I've left room for my pi r squared. I'm just going to stick that on right here, pi r squared. 45 over 360, that does reduce. So I always reduce whenever I can because I like smaller numbers. 45 over 360. So that's 1/8. So this problem will become 19.24 is equal to, okay, now here's my 1/8. So I have my pi r squared still in the numerator. I don't really need that 1 though, do I? Go away. So it's really just pi r squared over 8. Let's get r squared. We need to multiply both sides by 8. All right, that way the 8s will cancel each other out. So what is 8 times 19.24? So that's 153.92. And that equals pi r squared. Next, let's divide both sides by pi, and that will get r squared by itself. So we divide both sides by pi. So I've got this. I can just go ahead and hit divided by pi, and that gives us this. This is not the final answer, so let's temporarily keep 4 decimal places. So this is 48.9943. Okay, do not round this all the way down to 2 decimal places. That will give you too much error. Because the final step is we need to take the square root of both sides in order to get the r by itself. So now, what is the square root of 48.9943? That is 6.9995. So if I try to round this to the nearest 2 decimal places, I'm going to have to round this up to a 7. So this is really going to round up to r equals 7.00. The units are in inches. Well, area with square inches, so that means a length, like a radius, will simply be inches. All right, let's do one more problem. Problem number 7. The inner edge of a horse racing track has 2 straight sides, 1,300 feet each. So that tells us that this purple line right here is 1,300 feet, and this purple line here is also 1,300 feet. And 2 semicircular ends with a diameter of 820 feet. Okay, so this is a semicircle, meaning half of a circle. And this is also a semicircle. That is very helpful because if we put 2 semicircles together, we get a full circle. So if I do, maybe I'll put this off to the side for a second. If I have the semicircle from the left side of the track, and then if I do the semicircle from the right side of the track, if you put those together, it makes a complete circle. So keep that in your mind. We are going to need to know the radius of this hypothetical circle, which would be like right here. But what they give us is the 820 feet diameter. So let me just go ahead and draw this portion for a second. This whole thing is 820 feet. That means that half of that will be 410 feet. And that is the radius. So we now know that the radius is 410 feet. Okay, we need to find the area of the grassy region. So here's the thing. The area of the grassy region can be thought of as two parts. We have the area of the rectangle, and then we have the area of the circle. Okay, let's start with the area of the rectangle. The formula for the area of a rectangle is just length times width, or some people say base times height. Either way, that is going to be 820 times 1,300. So the area of the rectangle, if I can get my calculator going, length times width, all right, 1,300 times 820. So this is 1,066,000. Now, how about the area of the circle? Well, and be careful. I'm saying the area of the circle. What circle? Remember that if we take the two semicircles from the left side of the field and the right side of the field, if we put them together, it forms a whole circle. So really, we are talking about two semicircles, the left semicircle and the right semicircle. But if you put two semicircles together, you get a whole circle, and that's what I'm talking about right now. What is the formula for the area of a circle? It is pi r squared. So the r is 410. So it's pi 410 squared. Well, what is that? 410 squared. Okay, and I feel like we should just go ahead and put the pi in there. So let's go ahead and do pi 410 squared. All right, don't worry. The squared is only squaring the 410, not the pi. So, okay, we get this. You know what? I'm just going to leave it like this, actually. 168,100. So, so it really just only squared the 410. So I've got 168,000. What did I say? 100 pi. So I've got the area of the rectangle and the area of the circle made up of the two semicircles. If I add those together, that's going to be the area of the shaded region. So I'm just going to take these and add them up. Okay, well, I already have the 168,100 pi. So let's just take this and add the 1,066,000 and see what we get. Okay, so I'm putting in my little commas here. So this is 1,594,101. Let me write that much down. And what were those decimal places? 0.725. Okay, we're talking area. The lengths are in feet, so this will be square feet. Do not forget your units. So that's how you solve problems involving sector area.